Hi guys, this is Arvind Kalia, and today I'll be taking you through the basics of indefinite integration. Being very frank, this is the topic which is normally asked in school as well as in competition. So certainly that makes it very important topic. And normally students struggle in a particular kind of problems in this chapter. So what I'm going to do is, today I'll be telling you two things. Number one, what is the nature of this topic? How should you study this topic? And second thing, which part is mostly asked in competition? Okay, so I'll be making you learn these two basic fundamentals of the chapter, how to study this chapter, and which part will be most probably asked in competition. Let us begin. First of all, nature of topic. Guys, every topic has a different kind of nature and you need to study that topic as per its nature. In particular, indefinite is kind of very linked topic. What will happen? You will study something in the starting of indefinite. Let me call it 1. Using this 1, whatever you have learned in this 1, you will find some integrals of type 2. Without learning 1, you will not be able to learn second part. Then, after learning 1 and 2, you will learn next stuff, let me call it 3, which can only be learned provided you have learned 1 and 2. Then suddenly what will happen? 4 will come, which will be requiring all the 3. So what is the point? Point is, you just cannot skip any part of it. If you want to learn it properly, start from the beginning. Prepare the first thing the best. Then using it, you will be able to learn the second thing at the best level. Using 1 and 2, you will be able to learn third thing at the best level. And when you are good at all the 3, next category will come, which will be requiring all the 3. Okay, so that is the way you have to learn this topic. Do not skip any of the part. So learn every part and do not forget whatever you are learning, it will be used in the next part. So this topic is very linked, too much linked to be skipped any topic. Okay, this is the first thing. I'll tell you how exactly this thing works in indefinite integration. Of course, I'll tell you through some examples. Now, primarily, this topic involves 3 major topics. One is transformation, and second is what we call that as substitution, and third is by parts. Let me call the fourth one also partial fractions. You can also take it as one important part. Partial fractions. To be precise, everybody has his own preferences, but as per me, these two are the most important parts of this chapter. Transformation, by transformation I mean something is given to you which is not directly integrable. You just transform it using some tools and bring it into a form which is integrable. Substitution. You substitute something so that the integrand looks better. By parts. You know the product rule of differentiation, right? This is a corresponding thing in indefinite integration. By parts. Last is partial fractions. Today, what I'm going to do is, I'm going to pick substitution. If you learn this topic in this chapter, you learn everything. This is the most important key point of the chapter, substitution. So let me just explain the stuff through examples, and slowly, I'll take you to the point where you will realize, okay, this is something they ask in competition. Easy, damn easy. Let's start the journey, guys. So let me just explain the substitution or revise the substitution for you through these two examples, very basic examples. We want to integrate this thing. Moment we realize that derivative of this is there with dx, we substitute 4x squared plus 7 as t. So this implies 8x dx equal to dt. Therefore, our integral becomes 1 by 8 sine of t dt. Now we know the integral of sine t, so answer comes out to be minus cos of t plus c. Now substituting back, we get minus 1 by 8 cos of 4x squared plus 7. This is the answer. No issues at all. Basic substitution. Similarly, guys, if we look at second example, I don't think anybody will be having problem when I write this thing. Derivative of root x is 1 by 2 root x. You know that. I know you know how to differentiate, but it's even important to remember it as such. So if you remember directly, then you can see derivative of this thing is there with dx. Root x. A derivative 1 by root x. So clearly we will substitute 3 root x plus 4 as t. Certainly this thing gives me 3 by 2 root x dx equal to dt. So therefore my integral simplifies to 2 by 3 dt upon t square, and it's very simple now. So this is 2 by 3 into t power minus 2. So we increase the power by 1 and then divide it. Minus 1 by t. So the answer is minus 2 by 3. T was 3 root x plus 4 plus c. So that was like the quick revision of substitution. How do we substitute? If a term is there whose derivative is multiplied with dx, we straight away put that term equal to t. My expression simplifies, it becomes integrable, and then we integrate it. Two basic examples. Now, let me tell you how are they going to ask this thing in competition. Dekho beta, look at the first thing. What is the first thing you observe in this question? Clearly, it is not a standard format, first of all. Right? It is not at all a standard format. Second, guys, whenever you see some really big powers here, really big powers, power 4, and a bad power, 3 by 4, always substitution will help. If you observe carefully, in x power 4 plus 1 raised to power 3 by 4, if you take out x power 4, if you take x power 4 common, this will come out, and inside you will be left with this thing. So we will get x outside, x cube, and inside 1 plus 1 by x power 4. Let me take x power 4 common. X cube will come out. X square is already there, so we get x power 5. 1 plus 1 by x power 4 raised to power 3 by 4. It's done. Don't you think derivative of this is nothing but multiplied with d by dx? So we are going to substitute 1 plus 1 by x power 4 as t. This is going to give me minus 4 by x power 5 dx equal to dt. So I comes out to be minus 1 by 4 dt upon t raised to power 3 by 4. And hence you get your answer. T raised to power minus 3 by 4. You add 1, you get t power 1 by 4. And then you divide by 1 by 4. So minus t power 1 by 4. The rest all is good. But sir, how we will come to know that we should have taken x power 4 common? Number one is, of course, with practice. Number two, when you will have confidence that substitution is going to help, surely you will try to make it look like that something you have whose derivative is multiplied by dx. So in process of that, you will try to do this thing. Last, bottom line, conclusion. You always, I will not say sometimes, always take the biggest power here common. You will get your answer. Guaranteed. No problem at all. No exceptions. And I'll tell you how. In coming examples, just try to realize that. 2015 mains question, and such a simple question. Let me show you one more example. It looks even bad. By the way, it's IIT 2006 question. Bekar. Damn easy question. I know the moment I look at this question, I know it will be done by substitution, number one. And substitution will be done after taking something common. I know that beforehand only. How? Number one, it is not a standard format. Such big powers are there, power 4, power 3, big powers are there. Root, something bad is also there. Same. No difference at all. I'm pretty sure I will take something common, it will cancel out, and you will know what to put equal to t. Take x power 4 common. That is the biggest power here we have. Take it common. You will get x square outside, so it will become x power 5. Root of 2 minus 2 by x square plus 1 by x power 4. Clearly it divides. So 1 by x cube minus 1 by x power 5 divided by 2 minus 2 by x square plus 1 by x power 4. Guys, don't you feel that happiness when you see this and the numerator together? Don't you think this can be easily derivative of this? I too can easily see 1 by x square ka derivative will be like 1 by x cube. 1 by x power 4 ka derivative will be something like 1 by x power 5. So without wasting any moment, I'll straight away put 2 minus 2 by x square plus 1 by x power 4 equal to t. Try to see. Minus 2 by x square ka derivative will be x power minus 2, so 4 by x cube. And 1 by x power 4 ka derivative will be minus 4 x power 5 divided by x power 5. Dx equal to dt. So your I becomes 1 by 4 dt upon root t. It's done. Don't you think so? Simple. Now integral of root t is power minus half. You increase by 1, becomes half, divide by 2. So 2 root t. Of course, finally you put the value here and you get your answer. Look, initially this question might look horrible, but the moment you know it is including big parts, root, bad parts also, it should become very simple for you because you are pretty sure it will be done by substitution. No other method will work. Second, I just told you, don't you struggle much. Just take the highest power common. And that's all you require. You will get this type of thing where you will be knowing what should be put equal to t. It's done. IIT 2006 question, such a simple question. No? See? Okay. Still, if you don't believe, I give you one more example. Try to see. Bad parts, big parts. Now you must be knowing what you have to do. Something will be taken out common. After that, you will be putting something equal to t. After that, it will be done easily. And I need not tell you now, but you need to take common. The biggest power, obviously. So x power 15 comes out because it's cube here. Inside we have 1 by x square, 1 by x power 5. So far, you might be feeling afraid. Yeah, if it is not like a good thing, then I'm telling you, just have faith on me. It will be good. It will be really nice. Okay, let us see. Divide it. You get 2 by x cube, 5 by x power 6, divide by 1 plus 1 by x square plus 1 by x power 5. Guys, I'm to feeling that happiness. Look, I'm having 1 by x square, 1 by x power 5 in the denominator, and 1 by x cube, 1 by x power 6 in the numerator. Clearly, it can be derivative of that. So I'll clearly put 1 plus 1 by x square, 1 by x power 5 equal to t. It is giving me minus 2 upon x cube minus 5 upon x power 6 dx equal to dt. Guys, it's done. So simple. No? Minus dt upon t cube. Done. Finished. Do you think mains and advanced ask you difficult questions on integration? I don't think so. They ask you such questions in which you beforehand know what to do. Take something common, and that something is always greatest power. You will be knowing what should be put equal to t. Just put it equal to t. That's all. So mains or advanced will majorly ask such questions in the chapter indefinite integration. They have fixed pattern. Okay. So now you must be convinced by my argument that indefinite, especially in competition, is never tough, because they ask a particular concept almost every time. Why do they do so? Because this thing initially looks very bad. But the moment you know the catch, perhaps I am able to convince you that there is a particular catch. If you see that catch, question is done. Finished. Right? Okay. So that is like primarily what they ask you in competition. Now, let me give you one more example, which is a bit different. See, look at the question. It is also a previous year question, IIT 2002. In the first go, it looks really bad. We don't know what to do. But how do you categorize that what should be done? Number one, it is not at all a standard format. It's really bad. Bad powers are there. 3m, 2m, 1 by m, bad powers are there. Number two, if it is not good, not standard, something must be taken out, something must be adjusted, and then you will know what should be put equal to t. In this question, you will be requiring a little bit more of observation, which will come with practice. First, let me tell you how will I proceed. Then I'll tell you how did I come to know that I should proceed like that. What I did, from the first bracket, I take x common. I take x common. Sorry. 2m, 3xm plus 6 raised to power 1 by m. And then I entered this x in the second bracket. let me multiply this x in the second bracket. Guys, be careful. It has power 1 by m. So when we will take this x inside the bracket, it will become x power m. So when you take this x inside, it will become x power m, and hence you get 3m x power 2m plus 6 into x power m. Guys, now I'm seeing that this is really good. Its derivative will involve x power 3m minus 1, x power 2m minus 1, and x power m minus 1, which I'm clearly seeing here. So I will straight away try putting 2 into x power 3m plus 3 into x power 2m plus 6 into x power m equal to t. Straight away I'll try that. So what is the derivative? 6m x power 3m minus 1 plus 6m x power 2m minus 1, 6m x power m minus 1. Guys, I'm feeling very good. It's done. Don't you think? 6 power m comes common. So I becomes, this is dt, that is t. So t dt. Finished. So answer is 1 by 6 power 6m into t square by 2 plus constant of integration. And it's done. See, such an easy question they asked in IIT. And by the way, it was subjective question, that too perhaps 5 marks question. If you know that, before this JEE Mains and Advanced, there used to be like IIT by the name of IIT only, IIT Mains. So they used to ask subjective questions also. So at that time in 2002. So this was like a subjective question asked in IIT 2002, and that too for 5 marks as far as I remember. So this is your answer. Now, how did I come to know that I should have taken x common here? Look, guys, I'm pretty sure beforehand only, the moment I see this question, that something must be taken out, something must be adjusted so that we get something of this form. A term and a derivative of that term. Now, what were the various options? No doubt I am good at calculations, so I knew that if I take anything common from here, it will look really bad because of this 1 by m. So I should take something common from this term only. It is not having any power here. And now it was just mere observation that if I take x common, I'll be left with the powers 3m minus 1, 2m minus 1, and m minus 1. And moment that x goes inside second bracket, it will go inside, becoming x power m, which will make this term as x power 3m, this term as x power 2m, and this term as 6 into x power m. And hence I could see that I will get something whose derivative will be here. So at least now you know the direction in which you have to work. You get this kind of question, start thinking what should be manipulated so that I should be knowing that I have to put this equal to t. No other method will work. The moment you see bad powers, no, be convinced you have to substitute something. Okay. So let me just immediately conclude. First of all, these kind of question, Always take maximum power out and you will get to know what should be put equal to t. Similar variety, just take the maximum power out and you will know what should be put equal to t. Similar question, take the maximum power out and you will be knowing what should be put equal to t, right? Almost similar, but it required more efforts. So that is the major concept of substitution, and they ask you such substitution based question in competition quite recurrently, okay, quite frequently. So guys, this is something a brief about indefinite integration. So we will be learning such more things in the complete course, and for any further details of this course, you got to visit this link. Please, if possible, note it down. It will be better if you note it down, beta. You will get full details at this link. And what will be like we will be doing in this course is, if you think that today you learned something good about indefinite integration, then you can join this course. It is of about 6 lectures, about 1 hour 45 minutes per lecture. And in this, like a group of 6 sessions, we will be covering all the various tricks, standards, various approaches of this chapter, which will be asked in school as well as in competition till advanced level. Nothing will be left. Okay. And believe me, it is very easy chapter. Very easy chapter. By now you must have realized the questions which might be feeling very troublesome for you are actually very easy if you know the catch. Right? So same thing we are going to learn in this course. And of course, I'll be teaching that course. So that is like a brief. And about pricing, guys, you get to know about the pricing in this link. But otherwise, let me tell you, normally this course is for about 1,999 rupees for 6 sessions. But if you just visit this link and buy this course in about 2 to 4 hours, perhaps 4 hours after the session, you will get this complete indefinite integration course for just rupees 999. So if you think it's beneficial for you, it is not at all a big amount. And I assure you, after these 6 sessions, you will be champion of indefinite at least. Okay, no question will trouble you. Okay. Okay, let me just come back to 2 more questions. Let me show you the other side of substitution. Something we did was like one kind of application of substitution. This is another substitution application. Guys, if I look at this integration, certainly this term is troubling me. I'm not liking this root. Okay, you remove this root. What you got to do? You just need to put x minus 5 equal to t square. No? So dx is equal to 2t dt. And your I becomes x is t square plus 5. And root of this becomes t. And dx is 2t dt. So now root is gone. It is 2t power 4 plus 10t square, which can be easily integrated. This is 10 t cube by 3 plus c. And of course, finally, you put the value of t, root x minus 5. And here also, this. So this is also one of the application of substitution. If some bad part is there and you are not liking it, do this thing to remove that part. At least you will be having good parts to deal with. Similar question. You must be able to see that this root is troubling me. As such, this expression is not very good looking. This root is troubling me. Okay, we know how to remove root. Just put x plus 1 equal to t square. Nothing. Dx equal to 2t dt. Yes? So what is your I? This is t. Now dx is 2t dt. Divide by. What will be x minus 1? From here, x minus 1 will be t square minus 2. X minus 1 will be t square minus 2. Plus t. And guys, what it is? It is 2t square upon t square plus t minus 2. Guys, now, as I told you, what is the way of doing this chapter? You have to start from the beginning, learn the first part, then you learn the second part using first part, then you learn third part in which both of these will be used, then you learn fourth part in which all these three will be used. Sorry. So now is the time to realize that thing. Differentiation of quadratic by quadratic. Sorry, integration. Integration of linear by quadratic. These all are some standard formats of indefinite integration in which we learn the way to proceed. This is one of them. Using substitution, I have simplified my bad looking integrand. No roots are there anymore. It's really beautiful now. And how do I know that it is beautiful? Because it is one of the standard formats, right? So to learn this thing, we need full sessions now. I cannot explain that right now. So it is pending for the time being. We will be learning these skills. Of course, many of you must have encountered such things by now and must have covered the standard formats by now. It's like July and now. Rather, August has started, sorry. So still, these are some standard formats which we need to learn to proceed further. Okay. So that, guys, that was a brief about this chapter. I've told you the basic of this chapter, that how you should study it if you are struggling with this chapter. And I just explained what kind of questions normally they ask in competition. Okay. And I don't think you require anything more than that. So with that, let me just close down this session. Hope to see you soon. By the way, only 4 or 5 days are left for the chapter to start. So it will be really nice if you just make haste, click on the link I have provided and join the course so that you may learn indefinite integration in a really simple and efficient manner if you haven't learned it so far. Okay, in your school or anywhere. So that is all, guys. God bless you. Khush raho. See you soon. Okay, take care.